Hi everyone, this is Dr. White. We're going to go over chemistry today. That's this week's topic. So here are our learning objectives. So we want to be able to identify atoms, elements, and molecules, and compounds and ions. Those are our big vocab words for this session. When we look at a periodic table, we want to be able to determine the number of protons and electrons in an atom. And we want to be able to distinguish between ionic and covalent bonds. Then we're going to be able to identify hydrogen bonds and understand their importance in biological systems. So first, iClicker question. Go ahead and answer this in that iClicker assignment. Chemistry Part 1. What are living things made of? Things that are alive are made of. And the options are A, cells, B, tissues, C, vasculature, and D, thoughts. So go ahead and pause the video, think about that, answer it in iClicker, and we will move on. The correct answer is cells. So if you remember from those intro slides that we went over, the cells are the smallest unit of life. And as you can see on, let's see here, we're going to do my laser pointer. As you can see over here in this diagram, we've got life consists of units called cells. Cells consist of molecules, and molecules consist of atoms. So now we are going to go back to that smallest part, the atom. We're going to talk about atoms, and then we are going to move up in complication into molecules. Okay, so what is the difference between atoms and elements? Let me grab a pen color here. So atoms make up elements. And elements are made of atoms. Elements, particularly, are going to have, they're going to be atoms with the same traits. Okay, atoms with the same traits. So if you think about this, it's like elements are the category, and then the atoms are types of, are individual units of each type of element. So this is the smallest unit of matter. Okay, so like if we think about carbon, you can have an atom of carbon, but you can't have a carbon of an atom, right? So an atom makes up an element, but an element can't make up an atom. And all carbon atoms are going to have the same traits, right? And so let's talk about those traits in a minute. Next iClicker question. So we have this rhyme. Elephants are mostly made of elements. So all life on Earth is made up of primarily 4 elements. Go ahead and take your guess as to what those 4 elements might be. I'll give you a hint. I did just mention one of them. Okay, so we know carbon is one. And our other ones, pause if you haven't answered the question. Our other ones are nitrogen, hydrogen, and oxygen. Okay. So carbon, hydrogen, and oxygen make up the vast majority of our bodies as humans. This is oxygen. In the gray quadrant here, not quadrant, in the gray slice here is carbon. The blue slice is hydrogen, and the light blue slice here is nitrogen. Now, carbon is an element. It is a category of atoms. And carbon can be found on the periodic table of elements. right here. It is atomic number 6. Now that atomic number has a really important meaning when we are interpreting the periodic table. The atomic number tells us the number of protons. So take a moment, pause the video, answer an iClicker. Carbon has how many protons? How many protons? So if the atomic number is the number of protons, then carbon has 6 protons. Now, so we've heard atomic number, our element name is going to be here. The letter is our atomic symbol, and this bottom number is the atomic weight, which we'll get to in a minute. Now, there are 3 parts to an atom. There's the proton, the neutron, and the electron. And typically in any given atom, these are going to be present in the same quantities. So if carbon has 6 protons, and these 3 things are usually equal in an atom, how many electrons do you think we would have? Remember, our protons would equal our electrons. So carbon would have 6 electrons. All right, so now the parts of our atoms are also charged, or some of them are. Electrons have a negative charge. Protons have a positive charge, so electrons negative, protons positive, and neutrons are neutral. They do not have a charge. But over here in the mass of these parts, protons have 1 atomic unit of mass, and neutrons have 1 atomic unit of mass, but electrons are so small that they are not really considered as having mass. So they are atomic mass 0. So when we are talking about atomic weight, like down here, we are going to be talking about protons and neutrons. So if we have 6 protons and 6 neutrons, then our atomic weight is 12. Okay, and our atomic weight is 12. Okay, so the electrons are not counted in the atomic weight. They're still very important. The electrons are particularly important because they're not present in the nucleus. They are present around the nucleus. They are floating, orbiting the nucleus, meaning that they are available for making bonds with other atoms. So let's think about this for a second. Protons have a what charge? Electrons have a what charge? And then, given those 2 facts, what is the overall charge of a carbon atom? Okay, so let's think about this. We know that protons, according to our chart in the last slide, have a positive charge, and electrons then have a negative charge. So if we have 6 protons that are positive and 6 electrons that are negative, what would we end up with? What would be the charge? Okay, so go ahead and answer that if you haven't already, and we'll move on to these things called valencies. So electrons have orbitals, right? And these orbitals have layers. So the first orbital layer can hold 2 electrons. So the first layer can have 2 electrons. The second layer can have 8 electrons. Okay, so if we think about some atoms that we're familiar with, Hydrogen is up here. Hydrogen has 1 proton and 1 electron. So its electron hangs out in this first layer. And in that first layer, there's another empty space. And this empty space does not want to be empty. Atoms want to have a full outer shell. So this outer shell is called the valence. Outer shell is called the valence. Okay? Carbon has more than 2 electrons, so it has 2 shells. Its 2 electrons fill up the first shell that can hold 2, and so they start filling up the second shell. And electrons are negative, right? They don't want to be near each other unless they absolutely have to be. So in terms of our diagram, our electrons are going to fill these up one at a time instead of going in as pairs. So we're going to have, here's our first 2, 1 and 2, and then we're going to have 3. Stop right-clicking. 3, 4, 5, and 6. Okay? So none of those electrons paired with each other. So hydrogen has 1 empty space, so it wants to make 1 bond. Carbon has 4 empty spaces, so it wants to make 4 bonds. So, do we think that carbon and hydrogen could bond here? The answer is yes, but we'll get to that in a second. Okay, let's talk about ions really quick. So, carbon we talked about as being neutral. There are some elements where the arrangement of electrons in their valence shell makes them more likely to have a charge. So sodium here, sodium has 7. Is that right? 4, 6, 8, 10, 11. It has 11 electrons. 11 electrons. And chlorine had, oh my gosh, it's written on there. How silly. Okay. Chlorine has 17 electrons. So, sodium has this first shell full, 1, 2. The second shell also full. So we have 3, 4, 5, 6, 7, 8, 9, 10. So our valence shell for sodium is the third shell, right? And we only have 1 electron in this third shell. So there's 2 ways that an element, that an atom of an element can be happy. It can either fill up its valence shell, or it can get rid of electrons to go back to its last full shell. So sodium, since it only has 1 electron in its valence shell, is way more likely to give that electron away, as opposed to trying to find 7 more electrons to fill up that third shell. Chlorine is the opposite. Chlorine has an almost full valence shell. It has 7 out of 8 in its third layer. So if it tried to give away those 7 electrons, it would be ridiculous. So it wants to find 1 electron to fill up that last space in the valence shell. So sodium is going to give its electron to chlorine, and now they are going to be ionically bonded. So sodium can really easily give that electron away. If sodium loses a negative, what charge does it end up with? It ends up with a positive charge. Chlorine gains a negative. So it ends up with a negative charge. So that's how we end up with ions. Gaining or losing electrons gives us a charge, either positive or negative. Okay, so an ionic bond is really just electrons being attracted to other atoms. Ions of opposite charge positive and negative, want to be together. Okay? So, molecules are two or more joined atoms. So any two atoms that are bonded together are considered a molecule. So think about it for a second. Can a molecule does it need to have all different types of elements, or can it have the same element? So answer an iClicker, true or false. All molecules are composed of more than one type of element. And if you haven't guessed, we do have examples of molecules that have the same element. So we have O2 here and H2. So oxygen forms what's called a dimer with other oxygens. And that's how we have oxygen gas. Hydrogen does the same thing. It bonds with other hydrogens, forming a dimer, and that's how we have hydrogen gas. Okay? So let's think about this for a second. Cholesterol is a group of bonded atoms. Each of these little spheres is an atom. The gray spheres are hydrogen atoms. So the gray spheres are hydrogen. The dark, close to black spheres are carbon, and the red sphere is oxygen. So it has more than two bonded atoms. So which one of these could it be? So now we have another definition we need to talk about, which is the definition of compound. A compound is something made up of multiple elements. Okay, so cholesterol, not only is it more than two bonded atoms, it's more than two bonded elements. So it would be both of these, right? Both a molecule and a compound. And I'm going to let you guys think about whether or not it is also A, B, or E. So think about that as you are going to answer in iClicker. Okay, so the last thing we need to talk about are covalent bonds. So covalent bonds are when we have shared electrons. And these typically form between we see these in living things as bonds between our carbon, hydrogen, nitrogen, and oxygen, those four elements that make up most biological molecules. So, sharing of electrons. This sharing can either be equal or unequal. Okay, so that's where we get polarity. But let's talk about just a nonpolar covalent bond first. So in our slide here, we have a carbon atom and we have 4 hydrogen atoms. So I'm going to switch over to, it did not want to work. Yeah, okay, here's my, yeah. So now I'm over on the paint screen, if you can see my cursor down here at the bottom. So we have our carbon atom, and we have, actually let me put that in the middle. Carbon atom, and we have hydrogen atoms. Hydrogen, 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 hydrogen. Okay, now carbon, think about this for a second. It has 6 electrons, right? So it fills that first shell, and it ends up with how many in its valence shell? It's going to have 3rd electron, its 4th electron, its 5th electron, and its 6th electron. The valence shell can hold 8 electrons. So carbon wants to fill up those empty spaces. So if it has 4 empty spaces, it wants to make 4 bonds. Hydrogen, remember, has one electron each, right? So hydrogen wants to make one bond. If we have a hydrogen that wants to bond to a carbon, it would make a covalent bond, sharing its one electron with carbon. And so one hydrogen electron would pair with one of carbon's unpaired electrons, and we would form a bond. Okay. Now, carbon wants 4 bonds, so it needs 3 more hydrogens, right? So we have 4 covalent bonds here. And it is sharing these electrons. And these electrons are being shared equally, so this is a non-polar molecule. Non-polar. Okay? So our next option is a polar covalent bond. So in a polar covalent bond, one of the atoms pulls the electrons closer to it. It's not taking them away, it's just pulling them a little further away, like it's playing tug of war and it's winning, but it hasn't won yet. Okay, so let's look at our second example, which is water. Water is made up of 2 elements, hydrogen and oxygen. So we have our oxygen, and then we have our 2 hydrogens. Hydrogen and hydrogen. Now oxygen has 8 electrons, so it's going to fill up the first shell that holds 2, and then it has 6 more, so it's going to have how many blanks? 2 blanks. So it's got 2 pairs of electrons here. Actually, that's not how let's pair them correctly. 1, 2, 3, 4, 5, 6, right? So now we have 2 empty spaces. Hydrogen wants 1 bond. Oxygen has 2 empty spaces. It wants 2 bonds. So it can hold with it 2 hydrogens. So we're going to have 1 hydrogen paired here, forming a covalent bond, and 1 hydrogen paired here, forming a covalent bond. Oxygen shares those electrons, but oxygen is what we call electronegative. So oxygen pulls the electrons a little bit closer and ends up with a partial negative charge. Not a fully negative charge, because it's only holding the electrons closer. A partial negative charge. Hydrogen ends up with a partial positive charge. Okay? So this is what we call a polar molecule. This side is positive, this side is negative. Okay? So in our next video, that's going to have some interesting impacts. So go ahead and answer this last iClicker question, and we are done.